So I want to make a very clear distinction between two basic terms that we're going to use a lot in this chapter, and that is factor and zero. So let's just look at a very basic polynomial. So let's just look at x squared plus 3x plus 2. Very basic polynomial, right? It's a polynomial. And I could go ahead and factor that. Hopefully you guys are okay factoring this. This would be x plus 2 and x plus 1, right? And I could even go ahead and graph this guy. Because the way that I graph it is each one of these factors, these are both factors. So x plus 2 is a factor and x plus 1 is a factor. They're in parentheses, they're factors, okay? And because we factored it, remember factoring? So they are each called factors. And what I do is off to the side, I say, okay, x plus 2 equal to 0. I can subtract 2 from both sides, so I get x equals negative 2. So that means negative 2, this is a 0. I set it equal to 0. I set my factor equal to 0. And that means that if on my graph, at negative 2, I have I have 1 0 at negative 2. If I do the same to the other term, hopefully you can see that negative 1 is going to be a 0. And I can go ahead and connect that and make my parabola. Okay? So just be careful that make sure you understand. These two things in parentheses are factors. And then what makes them each, if I set each one separately equal to 0, then that's the 0. And that is where my polynomial is crossing the x-axis. Because, and the reason, they're set equal to 0, but also, I hope you notice that the point, negative 2 comma 0, is on the graph. This point right here was negative 2 comma 0, and this was negative 1 comma 0. Okay, so just make sure you really understand that distinction. So we could ask you so if I gave you a bunch of graphs and I asked you to find the zeros and the turning points, I could have a graph that maybe looked like this. We'll just make it a simple one for now. So if I asked you what my zeros were, your zeros would be negative 1 and positive 2. These are your zeros, right? They're your zeros. What if I asked you to turn them into factors? Could you turn them into factors? Well, sure. That would be x plus 1 and x minus 2. Those would be your factors. Do you see how that works? I could also ask you for the turning point. So where's your turning point? Well, your turning point is going to be your vertex, right? And I didn't draw this very well, but let's say, so this turning point in this instance would be what? 1 comma 2. That would be my turning point. Let's look at another example. So let's look at another example. What if we had something that looked like this? And I said, okay. Okay, so let's, what are our zeros? Well, our zeros are going to be, sorry, that's not very good. So our zeros are at negative 3, 0, and positive 4, right? That's where it's crossing the x-axis. And I could turn each one of them into factors, so it'd be x plus 3. This would just be x. And this one would be x minus 4. You could also think of this as x minus or plus 0 if you wanted to write it like that. That's totally fine. But we just write 0, just x. And notice that these are our factors. They have the opposite sign, okay? And we've done that before. And then what if we ask for turning points? So your turning points would be roughly, what is that, negative 1 comma 3 and 2 comma negative 2. Okay, do you see how there's two turning points, right? It's turning here and it's turning here. Okay, so let's pull this together one last way. So I want to look at this a little more closely here. So remember, we looked at the graph, we found our zeros, and then we turned it into factors. We took each one of the zeros and we turned them into factors. So in the past, you have taken an equation and turned it into factors. So let's see if we can go the other way. So over here, I'm just going to take this equation. Actually, let me see if I can delete some of this. Oops, I'm going to get rid of the turning points. We don't need that anymore. Oops. Okay, I guess I can't get rid of all that. Sorry. So now what I'm going to do is I'm going to take x plus 3 and multiply it by x minus 4, and then I'm going to multiply it by x. So let me just do, I can only do 2 at a time. So what I'm going to do is I'm going to FOIL out these two, okay? So we get, what is that, x squared minus 4x plus 3x minus 12. And I can combine like terms, x squared minus x minus 12. But then don't forget, we still have to multiply everything by x. So we get x cubed minus x squared minus 12x. So to bring this all around full circle, we looked at a graph. We found the points where it crosses the x-axis, and those are our zeros. We took each one of our zeros and turned them into factors. And then we can take our factors and FOIL them out into a polynomial equation. So if you were to plug into your graphing calculator this equation right here, your calculator would give you this graph. This graph, these two equations right here are the exact same equation. You could also, you can go ahead and plug things in factored form into your graphing calculator. As long as you use your parentheses, your calculator knows what to do with that. So you can put it in either this form or this form, but just understand that these two things mean exactly the same thing. They're the same name for exactly the same graph. Okay? So one more thing I wanted to show. If we gave you, what if I gave you p of x equals, x minus 2, x plus 4. I mean, you obviously know how to come up with your zeros now, right? Your zeros are going to be 2 and negative 4. So you could graph that guy. You'd have a 1, 2, 3, 4. You would have a 0 here and a 0 here, and it would look something like that. So you're good with that, right? But what if we gave you something that looked like this? What if I said p of x equals x squared minus 4 and x squared plus 16. So now I want to know what my zeros are. Well, what we're doing when we find the zeros here is we're setting this equal to 0, right? We're doing, we're not doing this because some of these are so easy we don't need to write them out, but x minus 2 equals 0, and then we add 2 to both sides, so we get x equals 2, and that's how we came up with that 2 right there, right? So this is a little more complicated, and it doesn't matter. Sometimes these factors are going to end up being trinomials. So that's okay. So what we're going to do is we're just going to go ahead and set that equal to 0. So x squared minus 4 equal to 0. So x squared equals 4. So x equals positive and negative square root of 4. Let me erase that. Oops. Well, apparently it won't let me erase it, so I'll just cross it out. So, square root of 4. So x equals positive and negative 2. So those are two of my zeros, positive and negative 2. Okay, that means that graph is crossing at positive and negative 2. So let's do the same over here. So we're going to have x squared plus 16 equal to 0, x squared equals negative 16, x equals positive and negative square root of negative 16. So x equals positive and negative 4i. So remember, when you have a negative under the square root, you have to have that imaginary number. So my other two factors are going to be positive and negative 4i. So I have 4 factors for this guy. I have 4 factors, which doesn't surprise me. We'll talk about this later, but this is a second degree, and this is a second degree. You add them up. So generally, you're going to have 4 zeros. But only 2 of these can I actually graph on an axis. I can only graph my real zeros. So this is going to be, it's going to look like a parabola. For all intensive purposes, it's going to look like one. It's going to have a 0 at positive 2 and negative 2. It's going to look something like this. But there are 2 hidden zeros for this guy. at positive and negative 4i. We just can't put those on the axes. Okay, so just be careful. Sometimes you are going to have imaginary zeros. So hopefully you've already watched the video on synthetic division, because that's going to become important right now. So we can also ask a question like, is 6x cubed plus 19x squared plus 2x minus 3? And my question to you is whether x plus 3 is a factor. Okay, so that's my question. I want to know, is x plus 3 a factor of that guy, of this large polynomial? Okay, well, hopefully what you just learned is you should realize that if x plus 3 is a factor, what has to be a 0? Well, that means negative 3 is a 0. So that's a question. And these two questions are identical, aren't they? If I want to know if x plus 3 is a factor, that's the exact same thing as saying negative 3 is a 0. So, using synthetic division, we now know that if we do synthetic division by negative 3, so if I divide this guy by negative 3 using synthetic division, if my remainder is 0, then negative 3 is in fact a 0. So let's go ahead and do that. So let's say negative 3, 6, 19, 2, and negative 3. Notice that all my factors or all my terms were there, and they're in descending order. I don't have to put any zeros in. So 6, this becomes negative 18. When I add straight down, I get positive 1. Multiply negative 3, I get negative 1. I get positive 3, and I get 0. Oh, and look at that. So if I end up with 0, if I have a 0 remainder, then negative 3 is a 0. And, like you just learned, x plus 3 is a factor. Okay?